This is the introductory video for the Physics 1101-1120 friction experiment. There is some pre-lab work for this experiment, so before coming to the lab, you should create a free body diagram for the box on the inclined plane and also for the hanging mass. From those two free body diagrams, you should derive an expression for the kinetic coefficient of friction, mu k. You should also get an uncertainty for that, and I'll warn you that the uncertainty calculation is quite long and painful in this case, so I've created a second video to help guide you through the process of calculating that uncertainty. As I said, this should be done before you come to the lab. To set up your equipment, the first thing you're going to want to do is put your pulley right on the end of the track here. So attach that by clamping it on, and the next thing you want to do is incline the track with this wooden block. However, you've got two little rubber mats that are going to keep it from slipping around, so you put one of them underneath the block, like that, and then the second one should go right on this corner. So right there. Next, you're going to put your wooden box on the track, but you also want to adjust your photo gate to the right height. So let me show you what I mean. The photo gate will go back here, and you want its height adjusted such that each of these tines on your picket fence is going to trigger the photo gate, but when the box slides by, it's not actually going to run into this. So you may need to adjust the height of the photo gate up or down, just to make sure that it's going to be triggered by the picket fence, but not colliding with the box. To accelerate the box up the track, we're going to use a hanging mass. So you take your piece of string, hook it over the hook on the box, run it over the pulley, and then the hanging mass dangles off of that. And then you should have the box accelerating up the track. Before you start taking data, however, you may want to move the pulley around a little bit on the track, because what you want is for the box to not be rubbing against the side of the track, and at the same time to not have the picket fence hit the photo gate. So you may need to offset your pulley a little bit to make sure that the box slides up the track without rubbing against the side and without clattering into your photo gate. So do a few trial runs before you start taking data, just to make sure everything's running smoothly. You're going to measure the acceleration using the Picket Fence program, which I'll show you on screen in a moment. And you'll want to do several trials and average them together to get an average acceleration, which is what you'll then use in your calculation of the kinetic coefficient of friction. Now, I would suggest that you should do at least 5 trials. In your calculations, you're also going to need the angle of the slope, which you get using this device. So you just sit it flat on the surface of the track, and then use the pointer to measure the angle that the track is at. You will also need the mass of the box with the picket fence in it, and also your hanging mass. Once you've got all the quantities you need to calculate the kinetic coefficient of friction, then you're going to repeat this for a different angle of the slope. To change the angle, all you need to do is flip the block to a new orientation, for example, like this. And you put your rubber mat in, and you will probably need to readjust the height of your photo gate again, so that again it's triggered by all the pickets, but doesn't run into your box. So again, take all the data that you need to calculate your kinetic coefficient of friction and its uncertainty, and the theory section of the experiment doesn't make this explicit, but the theory does predict that the coefficient of friction only depends on the two surfaces involved, not on the angle of the track. So your two mu values should agree with each other within uncertainty. Make sure that you compare them. To access the PhotoGate programs, look around on the desktop for a folder that says PhotoGate VIs, and double-click on that. This week we're using the Picket Fence program, so you can double-click on that to open it up. And there's a couple of things you're going to want to change before you start taking data. So up here in the corner, you see intervals to time. The default is usually wrong for your purposes. So the number of intervals to time is the number of intervals between the sticks on the picket fence. So you're not counting up the sticks, you're counting up the intervals. So 1, 2, 3, 4, 5, 6, 7, 8 intervals on this picket fence. You should count up how many intervals your picket fence has, and then enter that in the Picket Fence program for the number of intervals to time. The next thing you're going to want to change is this edge-to-edge distance or angle. The edge-to-edge distance is defined as being from the front edge of one of these sticks to the front edge of the next one over. So not outside to outside, not inside to inside, but from the leading edge of one to the same edge on the next one over. So you take your ruler and you'd measure from the leading edge of one stick to the leading edge of the next one over. And then you'd convert that value into meters, and that would be the quantity that you type in for the edge-to-edge distance in the Picket Fence program. Once you've changed your intervals to time and your edge-to-edge distance, you're ready to take data. To take data, you want to click this button up in the corner that has a single white arrow on it. There's also another button right beside it with 2 arrows. Do not click that one. It's not the one that you want. So you would click this white arrow, and that would prepare the program to take data. When your picket fence goes through the photo gate, the program's automatically going to capture data. So let me show you what that looks like now. So I click the button with the single white arrow. That starts the program running. And there is a little light down here at the bottom. You should wait until this turns green before you start taking data. So right now my program is ready. So I can start taking data. The program captures it for me and graphs it. Now this is a distance versus time graph, and normally what you want is the velocity versus time graph so that you can then get the acceleration from your slope. So the program allows you to look at the velocity time graph. Down here at the bottom left-hand corner, there's a little button, and if you click the button, it switches between the distance time graph and the velocity time graph. Now there's one thing that's a little glitchy about this button, and that is that there's a double-headed arrow right in the middle of it, and if you click that arrow, nothing happens. But if you click anywhere else on the button, it functions normally. So just be aware of that little glitch. So you should look at your data on the velocity time graph, and you should check whether it looks linear. The program automatically fits a straight line through it, but you should check that your data points are not falling very far away from that line. If they are, you should probably tweak your apparatus and try the experiment again. So assuming your data looks nice and linear, then you can write down your acceleration value, which is over here on the left-hand column. If you need to retake your data, down here is a pink button that says cancel. You click cancel, and then you won't be able to look at your other graphs anymore, but it does give you this single white arrow button again. So you can set your equipment up again, click the button with the single arrow, and then take data again.